Hi and welcome. Thank you for joining me in this Azure Back to School session. My name is Maarten De Moor. I'm a cloud engineer at Exilus, and today I would like to introduce you into modernizing applications with containerization and PaaS solutions. We have a lot to cover, so let's go. What can you expect from this session? I will start with the why. Why should you modernize your applications and what are the benefits? Then I will show you an overview of the current environment, the demo environment, which we will use throughout this video. I will show you the architectural overview multiple times during this session as we make progress through our modernization process. I will also show you a few options, and when you modernize your application and your database, there are often a few options to realize that. So I will show you a few, and then we will choose one, and then I will demo the chosen modernization option in a hands-on demo. Okay, so let's start with the why. Why should you modernize your application? Well, when you modernize your application and you introduce containerization or you use PaaS solutions, you can focus on your application and you can focus on the development of your application, and you no longer need to worry about patching your OS, updating your OS, making sure everything keeps up and running. That means that you have less maintenance on your applications. That lowers the cost of ownership. You can focus on your application, on the development, and when you use, let's say, DevOps with CI/CD, you can also fasten the development cycles, which then results in a lower cost of ownership. You can, with a lot of PaaS solutions, you can also enable easily high availability scenarios and scalability. When you use web apps in Azure, you can let them scale out according to the capacity that's needed. You can also place multiple instances of your web app in different regions. And let's say you have customers in Europe, then you can place a web app in West Europe, but you also have customers in Asia, then you can also place a web app instance in the Asia Azure region. I have prepared a demo environment for this video. So I have deployed an app server and a database server. The app server is running EES and it contains a ASP.NET application. The database server is running Microsoft SQL. The app server connects to the database over the default port, so that's 1433. And we will use HTTP to connect to our app server, just so we can focus on the functional part of our application and we don't have to worry about HTTPS. Okay. At the end of this session, we will replace our on-premise app server by a web app, and our on-premise database server will be replaced by a Azure PaaS SQL Server containing one SQL database. Okay, let's dive into the demo. I have divided the session in two parts. The first part will cover the modernization of the database. The second part will cover the containerization of the application itself. When you are migrating or modernizing your database to Azure, there are a few options. First of all, you can deploy an Azure virtual machine in Azure and then deploy your SQL Server on that virtual machine. Actually, you're lifting and shifting your SQL Server to Azure, and you are still responsible for the updating and patching of the underlying operating system. The second option is a Azure SQL Managed Instances. That actually corresponds with a Azure SQL Server, but with the difference that you do not longer have to worry about updating and patching. You also don't have access to the operating system. You just have access to the SQL Server, which you can just open in the SQL Management Studio. So all features are almost the same. Then the third option is that you just create a simple standalone Azure SQL database. So you just create a database and you add your data, you add your structure, and that's it. Okay, so now that we know what the options are, let's switch to the on-premises database server. When you are going to migrate your database to Azure, there are a few options to do that. You can create a backup of your database and then restore it into Azure, or you can use a tool like the Data Migration Assistant of Microsoft. And that's actually a tool which does two things. First of all, it will do an assessment to check if your database is compatible with Azure, and it will then perform the migration itself. It will export your database scheme, your data, and will import it into Azure. Before we can do this, we first have to create a database server and a database, a SQL database. So let's switch to Azure. Okay. You then have to search for SQL database, and you choose for create. As usual, you have to choose a subscription and a resource group. You then specify a name for your database. I will choose for ticket verkoop voetbal. I will use the same name as on premises because that's just a bit easier. When you change the name, you also have to change it in your application. So ticket verkoop voetbal. When you do this for the first time, you also have to create a database server. So let's choose for create new. First of all, you have to choose a globally unique name for your server. Let's try and see if Azure Back to School is still available. Okay, looks like we're lucky. I changed my region to West Europe. I will use SQL authentication for my database. So I use the same credentials as I use online, like this. Okay. Then you click on OK, and it will deploy a SQL database server. Now, because it takes some time, I have already prepared this, so I can just choose the one I've created earlier to continue. It asks if I want to use a SQL Elastic pool. We will not do that for now. You choose the type of workload the SQL database is running. It's actually a new option. So for now, I will just choose production. You can also choose a SKU for your compute and storage of the SQL database. I will just leave that by default. I'd advise you to take a look into the options and also use the Azure cost calculator to see which one is within your budget. For backup storage redundancy for this demo, it's just sufficient to use locally redundant backup. Then the second part is networking. You can choose how your SQL database will be accessible. I prefer to use a private endpoint so that I can access my SQL database over the internal network instead of via the public network. To create a private endpoint, you click on the Add Private Endpoint button. You then have to specify a name for your private endpoint. Let's say Azure Back to School. You also choose a virtual network to where your private endpoint will be deployed. In my case, that's this one. You then choose a subnet to where your private endpoint will be deployed. Let's say the backend subnet. And then a very important option is to enable the integration with a private DNS zone. By doing so, you make sure other resources like a web app are able to connect to your SQL database over the internal network. So when a call is made to your SQL database by using the host name, the private DNS zone will give the internal IP address of your SQL database, and by doing so, it's connecting over the internal network. So what actually happens when you create a private endpoint is that a network interface card is created, which is then connected to your SQL database, and by doing so, you have connectivity over your internal network. Since I have already created a private endpoint earlier, I will discard this for now. Okay, I will leave all these settings by default. We then have security. We have the option to enable a Microsoft Defender for SQL trial, but I will not do that. Okay, I will leave all the other options by their defaults. Here, that's an interesting option. You can choose to use existing data. There are three options actually, or you deploy a empty database, or you restore from a backup, or you can also use a sample database for testing. As we will use the Microsoft data migration tool, we will just deploy an empty SQL database. Okay, the collation is just fine. The maintenance window is also fine. Tags, always interesting to add some tags so that you know what is running within that database, but I will just leave that as is for now. Okay, so we can then create our database. So I will just confirm that. Okay. And once the database is successfully deployed, we can return to our on-premises database server, open the data migration tool, and then go through the steps. Let's wait a few more moments so that the deployment can finish. Okay. We will now, it will succeed in a moment. So I will already switch to my on-premise database server. I have already opened the data migration assistant. I create a new project, and I can then choose which type of project I want to add. I will now just use for migration. In the interest of time, I already know that my SQL database is compatible with Azure, so I will just skip that for now. You can specify a project name, let's say Azure Back to School. You then choose a source server type, which is SQL Server. Our target server type is an Azure SQL database. And we want to migrate both our schema and data. So that's all fine. Okay. Now we have to specify our source server. Since we have opened the data migration assistant on the database server, we can just choose for local host. Windows authentication should work. We then try to connect. Okay, that's good. Okay, we now just move on to the target server. You have to specify your you have to specify the server name of the SQL database server that you have deployed in the previous steps. Where can you retrieve the server name? Well, you just go to your SQL database server, which is, in my case, here. So here it says server name, Cloud Camp Live database server 1. So I just copy the server name and paste it into my database server. I have chosen for SQL Server authentication, so I just specify the username and password. Let's hope we're lucky and the password is correct in the first attempt. Let's try. Okay, yes, we are lucky. So you can see here that it has found one database, the one that we have created in Azure. So we will choose that one as target database. Okay, let's move on. Now it will retrieve the database scheme, and you have the option to choose certain tables or to include or exclude certain tables, but we will just migrate all tables. It will then deploy or generate a SQL script with a lot of code, which will generate your scheme, will generate the relations between databases, will add your data, and so on and so on. You could save this, you can verify if everything is just fine, but I will just click on deploy schema. It will then execute all those commands, and as you see, yeah, that actually went very fast, but it is a demo database, so it doesn't have a lot of data. In a live scenario, this step might take some more time. Okay, then we are ready to migrate our data. You can again choose if you want to transfer all data. Yes, I will do that. So start the data migration. Okay, and we then have to wait until it finishes. And yes, we can see here we have 14 successful executed or transferred tables. That means that our data is now available in Azure. We can actually verify that by using the Microsoft SQL Server, the Server Management Studio. So you can connect to a Azure SQL database just like you would do with one on-premises. Okay, here it is. We enter the server which we will connect to. So I have copied the host name of the SQL server. Okay, we use SQL Server authentication, and we then choose connect. We can then check, and we see here is our ticketverkoop voetbal database, and we can also check if all tables are here. Yes, that's the case, and we can even check if the data is in our tables. So let's select the top 1000, and yes, we see that all our data is available. Okay, the next step in our process is to let our on-premises app server use the database server in Azure. So let me first open or connect to the on-premises database. Okay, and I will first stop the database. Okay, yes, I want to do that. And when we now return to our application, we will see that it has lost its connection to our database. So it will do a few attempts to connect. I have made a typo. Okay, so it's now attempting or doing a few attempts to connect to the database, but it will eventually show an error message. We will now change our connection string in the application so that points to our SQL database in Azure. It now shows the error message. So let's go to our application server. And I have already opened the application code. And the only thing that you have to do is to republish your application. So I will go or choose publish. And here under show all settings, and then under the option databases, instead of referring to the IP address of the on-premises database server, I will enter the host name of the SQL database in Azure. Let me actually retrieve the host name again. So that was this one. Now return to the app server under databases, and then just change the data source to my SQL database in Azure. Since I haven't changed the database name, username, and so on, I just can click on save. Just one weird thing, when I want to republish my application to my IIS server, it gives a conflict because IIS wants to use the folder where I have previously published my application, and the publishing tool will try to write to that folder, but that doesn't work. So I first have to stop the IIS server, and then I am able to publish or republish my app. So let's stop it. Okay. And once that's finished, okay, I just can choose save and publish. So it will now republish and rebuild my application. And once that's done, we shouldn't forget to restart the IIS service and then try again to load our application. So, okay, start our app server. That's done. Let's return to our web browser and try again. And let's hope we are lucky and that we can connect. Yes, we are lucky. We can connect to our SQL database. So actually, that's it for the first part of the demo. When we now take a view at our environment, we started with a on-premises app server and a on-premises database server. We have eliminated this connection, and our app server is now pointing to our SQL database in Azure. The next step is to modernize our app server. Okay, let's now move on to the second part of this demo, the application. There are again a few options. First of all, you can just rehost it to an Azure virtual machine. So you deploy an VM in Azure, you install the IIS service, you redeploy your application, and you're good to go. The thing is that you still have to worry about updating and patching your operating system. Your second option is to do a full rewrite of your application. That might be a nightmare for developers, but you rewrite an application in a way that is ready for the cloud. I'm actually not an expert on that, so I will choose for the third option, which is containerization. We will put our application in a very, very small virtual machine, which has all needed or all required services to run our application. Okay, let's now switch to our app server so I can show you how you can containerize your application. So my app server is here. We will use Docker to generate our container image, and a Docker image requires a Docker file. You just create a new file named Docker file, and you place it in the root of your project. And in that file, we describe the steps needed to build our image. Luckily for us, we don't have to write scripts to, let's say, install the ASP.NET runtime. No, we can make use of base images. With Docker, you can make use of images published on Docker Hub. Let me quickly show you. So you go to hub.docker.com, and here are a lot of images, base images that you can use. Let's say Nginx. Here it is, Nginx. You also can recognize official images with these with this tag. So I really recommend to use these. And you then just open one, and here here it's described how you can consume it in your images. Okay, so I did that for the ASP.NET runtimes. So you can see I here do a import statement. So the syntax is from, then the URL of the base image, and I give an alias to it so I can use it here or can use it later. Then you specify the directory to where the image has to be unzipped. We also have to open the ports we want to use, because otherwise Docker container won't listen to any ports. So we expose port 80 and port 4043. We also need the SDK, so just like we imported the runtime, and you again specify the folder to where the image has to be unzipped. Then I use the copy statement, which will actually copy all files in my solution into the image. Then next, you always have to build a .NET application. So I run. Run stands for a command you run, and then it just actually is a .NET commando. So .NET builds the solution I'm using or the project I'm using. This indicates which config I will use, and -o is the folder to where all files will be written. I do the same for to build the application. So I will no, actually, excuse me, I will publish it in the next step, and then everything comes together in the final step. Once we have a Docker file, we have to generate an image based on that file, and we will push it to a container registry in Azure. I have chosen for an Azure container registry because you can easily use an image from that container registry in a web app. So I will use a pipeline in Azure DevOps to generate an image from this file. So let's switch to Azure DevOps. And we are again lucky because in Azure DevOps there are already a few template pipelines that we can use to realize to this. We choose for create pipeline. It asks where is my code located. Okay, so it's also important, very important, that you first upload your complete code with your Docker file to a repository, and you can then choose Azure repo git. I choose the ticket verkoop football repository, and it will then choose which template I want to use. And the second one is the one that we need. We want to build a Docker image first, and we will then push it to our Azure Container Registry. So let's choose this one. It will ask for a few parameters. So we have to choose our subscription, where our Azure Container Registry is located. Actually, we haven't done that yet. So let's first go to Azure and search for Container Registry. You create a new registry here. You choose your subscription. You choose a resource group. You specify a globally unique name, let's say Azure Back to School. Well, I've actually already used that one, so let's just add a number. I want to deploy it in the Azure West Europe region, and then I have to choose a standard. I really recommend to check in the Azure calculator or the Azure docs which SKU you need. Normally for the demo purposes, it would be sufficient to use the basic SKU, but I will choose the premium SKU because I want to use a I want to use the internal network to connect to my container registry instead of using the public internet. And to do that, you go to networking and I choose for private access. And here I create a private endpoint. Just by clicking the button, you specify a name and you're good to go. The encryption settings are just fine as they are. You can also specify some tags. I really recommend to do that, but I will leave that as is for now, because it takes some time to create a container registry. I have already prepared that, and mine is just here, Azure Back to School. Now we have to first prepare some things to make sure our pipeline can run in the first stage, and also when we deploy our app service in a bit, that the app service can reach our container registry. So under access key, you have to enable the admin user, and it will show a username and password which you can use to connect to your container registry. Actually, we won't have to enter our password, but you do have to enable the admin user. This is actually not a very secure way to do it. In real scenario, you use a managed instance instead to connect to your container registry. But for now, that is just fine. And I prefer to make my container registry only accessible through the internal network. So I choose for private access here, and I have already added a private endpoint connection. Okay, so that's all fine, and we can now go back to our pipeline. So we now choose a subscription. I have deployed my container registry in the sponsored subscription. I choose my container registry. I specify the name I want to use for my image. Let's just go for ticket verkoop voetbal. And then you have to specify where you have located your Docker file. If you have placed your Docker file in the root of your Git repository, you can just leave the path as is. Otherwise, you have to change this to match the location of your Docker file. So let's choose validate and configure. It will now generate a YAML file with the different steps of our pipeline. Now, by default, it will use the build agents of Microsoft, but because I've decided that the container registry can only be accessed, it can be written to or pulled image from over the internal network, I have to use a self-hosted agent instead, which has access to my container registry over the internal network. So instead of specifying a VM image, I just specify the name of a pool, which is in my case, and I have to verify, I thought it was Cloud Camp Live. Yes. And we do not longer need the VM image name variable. So let's just delete this, and we can just leave all the other things by default. Now save and run our pipeline. And when we take a look at our pipeline, the first time you do this, you have to give your pipeline permission to your hosted agent pool. So let's actually give that permission so that it can continue. So permission granted, and it is now waiting to be executed. Okay, there it goes. And what I want to show you in this steps is that you can see here, it will run through each step of the Docker file. So consuming the base image, running, and so on and so on and so on. This will take a while, so as soon as the pipeline has been finished, I will come back to you. Okay, so as you can see, the image was pushed to my container registry. Let's actually verify if that's the case. So I open my container registry and I go to repositories, and I see the ticketverkoop football repository, and it has, or it contains, one image with the tag 1845. Okay, so now we have our application contained in a container image. The next step is to deploy a app service or a web app, which will then use our or run our container. So we go to the homepage of Azure, and we take a look, or we search for app services. I click create, and I then, as usual, select a subscription, a resource group, and then I have to specify a unique name for my web app, which is also the URL for the web app, the default URL. So I will choose for ticketverkoop football. I then choose for Docker container, because we have generated a Docker container. It's a Linux-based Docker container, and our Azure region is West Europe. When you create a web app for the first time, you also have to create an app service plan. App service plan actually represents the compute power that you have available for your web app. Again, I advise you to check the different available SKUs on the Azure Docs and use the Azure cost calculator to see which SKU fits your needs and your budget. I will just leave that for now. I will clean up all resources at the end of this session. Okay, so the next step. In the next step, I choose which Docker image I want to use. So it is a single container, and it is you choose where your image is located. In my case, it is an Azure Container Registry. You choose your registry, your image, and your tag. Then let's take a look into networking. Actually, we don't need that for now, so we leave that by default. Monitoring, you can enable application insights to check the performance of your web app. Again, some tags to add, and then you get an overview and you can create it. Again, the deployment takes some time, so I have already prepared this, and my web app is ticket.be. Since I've deployed the web app before my container registry with my container image was available, I have used a temporary image. So let me quickly show you that's the case. So it just shows the default content when you deploy a new web app or a new app service. So let me first switch to let's choose our the image with contains our application. So it is stored in an Azure Container Registry in the sponsorship subscription. We use the admin credentials. Earlier we have enabled this one to let our app servers connect to the container registry, but as I already said, it's preferable to use a managed identity. I choose my container registry, Azure Back to School. I choose my image, ticket verkoop voetbal, and there's only one version, so I choose the only available tag. And I just save by clicking save. And in a few seconds, it will deploy my container image to the app service. There's actually one more thing we should do before our app service is able to connect to our database. When we deployed our SQL database in Azure, we decided that it can only be accessed over the internal network. So we thus have to VNet integrate our app service so that it can reach our SQL database in Azure over the internal network. In order to achieve that, we have to go to the networking tab under settings, and we then select the VNet integration feature under outbound traffic. You then click on add VNet and select the virtual network to where you have deployed your SQL database. In my case, that's this one. You have to create a dedicated subnet for your app services. So I click on create new subnet. You then have to specify a subnet name, let's say app services. You choose a virtual network address block. I only have one, so I picked this one. And then you specify a address block for your subnet. Normally, I advise to create a subnet as small as possible to not lose too much IP addresses. But in this case, I will just continue as I did with the other subnets. So in this case, this is the 10.1.3.0/24 range. Okay, I now confirm by clicking OK. Et voila, now our web app is VNet integrated. We can now check if our application is reachable. As we then, if we then refresh, it might take some time. Let me actually open it again. Sometimes there is some caching in place. Just to be sure it's a caching problem, I will open another browser. Yes, okay. No, it's still showing. Yeah, okay, now it's, yeah, I know it's coming because it's taking some time to load, and that's because it tries to connect to our database, which will not work since we haven't specified or haven't configured a we haven't configured a connection string yet. So let me return to here, and it will now show up here too. When we used when I deployed my on-premises app service, I configured my connection string in the publish settings. Now for an app service, it's a bit different. You go to your app service, and under the configuration tab, you can specify connection strings. So I click here on new connection string. I choose the name DB connection. This name is very important because it's the name to where the application refers. It really have to be the correct name. Then the value, I have saved the connection string. I thought it was on the app server. Yes. Okay, so I have written it here. No, it's not this one, but this one. So I just copy my original connection string. I copy it here, but instead I use the host name of my SQL database. And let me actually check again which was the host name. So here it is. I just replace that IP address by the host name. I can leave all the other things as they are, and the type of connection string is a SQL server. I verify or I confirm by clicking OK, and then don't forget to save here at the top. And it will actually restart my application so that the connection string is actually published as an environment variable into the web app, and the application can then make use of that environment variable to connect to the database. So let's continue, and it is restarting. Okay, and let's hope we are lucky again and reload our web app. It will now try to connect to our database. It gives error 502, but I think that's just because it's in the process of switching. Okay, so as you can see, it's now connected to our Azure SQL database. So actually, we are about at the end of the demo. I just want to show you one more thing. As you can see, by default, an app service has a something you've chosen, .azurewebsite.net. Preferably you want to use your own URL and your existing URL. How can you do that? You return to your app service, and then let me actually think which was or where it's located. I think it was under configuration. No. Then it must be under here. Here it is, custom domains, and you can here add your custom domain, and you will have to verify your domain ownership with a DNS record. It's actually really well described, so you can just follow the steps, and then you're able to use your own URL. Okay, so that's it actually for the demo. To wrap up, let's take a look at some takeaways. Modernizing your application comes with a few perks, like less maintenance, and you have also a lower cost of ownership. And as we did in this video, you can use PaaS solutions like a SQL database, and you can use containers in combination with an app service to deploy your application in Azure without having to worry about patching and updating your operating system. Okay, that's it. Thank you for joining me in this Azure Back to School session. I hope you liked it, and if you want to get started with yourself with the demo, I have or I will publish all application code and all infrastructure code on my GitHub account, which is just my name, and you can then just follow along with this session. If you have any questions, you can reach out to me via LinkedIn, or just leave a comment in the section below. And yeah, this was actually my first session as a public speaker. I hope you liked it. If you have any feedback, any tips for me, then please leave them in the comments. Thank you. Bye.